Hello all COMEDK 2025 aspirants. Today in the most expected series of COMEDK, today I am going to discuss the two chapters, magnetic effect of current and magnetism and matter. So here from these two chapters we are going to discuss a very important 15 questions, and what I realized is that the questions which are coming from this chapter are not super repetitive as it is in case of KSET. So anyone who is preparing for KSET as well as COMEDK, the question level from this chapter is slightly higher than that of KSET, okay, and you have to remember a lot of concepts and lot of different formulas to answer those questions. So this chapter is very scoring in KSET, this is scoring in COMEDK as well, but you have to remember a lot of different things than that you have already done in your KSET. Okay, let's see the questions. A very long conductor carries a current of 1 ampere. The magnetic field at a point whose distance is 0.1 meter from one end of the conductor is. So we have a very long conductor, okay, and magnetic field at a point whose distance is 0.1 meter from one end of the conductor. So from one end of the conductor, 1.1 meter, what is the magnetic field over here? Now the wire is long, but we are not finding the magnetic field at one of the centers, right? So what we will do, we will consider another wire, imaginary another wire, which is extended same way but in the opposite direction, okay, and the current is continue to flow throughout the conductor. Okay, now what is the magnetic field due to such wire? Magnetic field due to such wire is B equals to mu naught by 2 pi I by R, right? This is the formula for a straight wire carrying current. Now this is for the entire wire. Now if we consider half of the wire, so what will be the magnetic field that we are trying to find? That should be half of the magnetic field due to wire, right? Here it is due to two continuous wires. So for one wire it will be half of that. Okay, so whenever they ask you to find the magnetic field on the edge, you have to remember that you have to find the half of the actual magnetic field, which is equals to half into mu naught is 4 pi into 10 to the power of minus 7 divided by 2 pi into I is 1 ampere and distance is 0.1. okay, so 2 cancels, 4 cancels, pi cancels, and 0.1 will reduce one of the 10 to the power of minus, it will be 10 to the power of minus 6. Okay, so correct answer is 10 to the power of minus 6. Okay, very careful, it is not 2 into 10 to the power of minus 6 but only 10 to the power of minus 6. Now let's see another question. A voltmeter can measure 2 volt, is constructed by using a galvanometer of resistance 12 ohm, and that produces a maximum deflection for the current of 2 milliampere. Then the resistance R is, okay, so we have the resistance of the galvanometer, say R equals to 12 ohm. This one is unknown, and when we apply a voltage difference of 2 volt, we get a current of current through the galvanometer 2 milliampere. Okay, so this is the current. Now how to solve this? Easy formula. V is equal to IR, our old friend Ohm's law. So V is 2 volt, okay, I is 2 milliampere, and resistance is galvanometer resistance plus unknown resistance, right? So 2 cancels, we get 12 plus R equals to 10 to the power of 3, that is 1000. Okay, so this will come this side and become plus. So R equals to 1000 minus 12, that is 988. Okay, so 988 ohm. Correct answer is option B. you have to solve such questions. If you see some questions which is answerable easily, you don't have to waste too much time. Okay, the process does not matter, how quickly you can solve, that matters, right? And if you want to practice more and more questions, then Abhyas KSET test series is for KSET students. Those who are preparing for KSET, they definitely should consider this. The price is $14.99, but our manager forgot to switch off the offer which is currently going on, which was there yesterday, and it is there now by default. That is KSET $599. if you apply this KSET 500, not 599, KSET 500. If you apply this coupon code, you will get flat 500 rupees off on this price. Okay, because your KSET exam is near, we want more and more students should take advantage of this, and that is why we have decided to give you the offer of 500 rupees off. More than 1000 students already registered, and if you are one of them, if you are not one of them, then go into the link below and register yourself, right? And for all the COMEDK aspirants, COMEDK, we are launching a full crash course which is priced at 1999. The app will be launched very soon. It is almost ready, and very soon you will get the update, those who have already purchased, and those who want to purchase, go and purchase it now today. Okay, now next, a straight wire of length 2 meter carries a current of 10 ampere. If this wire is placed in a uniform magnetic field of 0.15 Tesla, making an angle 45 degree with the magnetic field, the applied force on the wire. So what is the formula? Applied force on a current carrying wire is BIL sin theta. Okay, B is 0.15 Tesla, current is 10 ampere, length is 2 meter, sin theta is sin 45 degree. Sin 45 means 1 by root 2. Okay, so do the multiplication. 10 into 0.15 is 1.5, 1.5 into 2 is 3, so it will be 3 by root 2. So 3 by root 2 is the correct answer. Now next question. Now this is a very interesting question, one of the previous year questions. An equilateral triangle, here we have an equilateral triangle, okay, of side 4.5 into 10 to the power of minus 2 meters, 1 ampere current is flowing. Find the magnitude of B at its centroid. Find the magnitude of B at its centroid. Now for this you have to know two things. Okay, one is the magnetic field due to a finite wire. Okay, if you have not remembered the equation, not remembered the formula, this formula is not important for KSET, but this formula can be coming in your COMEDK, as you have seen there, right? And one more thing, you have to remember the geometry of a triangle. Okay, so specifically equilateral triangle. What is that? That the median is given by root 3 by 2 into side A. Okay, this is the median's length. Also you have to remember that at the centroid it divided into a ratio of 2:1. Okay, so it is getting divided into ratio of 2:1. Now this is an equilateral triangle, so all the medians are same, so and all of them are 2:1, 2:1. Now if you see this wire, okay, and we are trying to find the magnetic field at this point, so the distance we consider is this one. Okay, so the entire distance is root 3 by 2a. So what is the distance of this? So for that you have to use the formula for ratio. So ratio is the entire length is root 3 by 2a, and this is 1/3 of the entire length. Why? Because the ratio is 2:1, so it will be 1/3 of root 3 by 2 into a, so it will be root 3, so you will get a by 2 root 3. So this is the distance from the center to any of the sides. Okay, now magnetic field due to a wire. Okay, so this part is done. Now let me erase the markings. Now what is the magnetic field due to a finite wire? So magnetic field due to a finite wire, suppose this is a finite wire, I want to find the magnetic field at this point. So this is the distance. So what is the formula? So this angle, suppose this angle is theta 1, this angle is theta 2. So you have to remember that the magnetic field due to a finite wire, finite length of wire is given by B equals to mu naught by 4 pi, okay, I by R is this distance obviously, times sine theta 1 plus sine theta 2. Okay, this is the formula. So this formula we are going to use over here to find the magnetic field due to a single wire. Then we have to multiply them with 3 because all of them will be added over here. Okay, so we have to multiply it with 3. So first we will consider this wire. So what is the magnetic field due to that wire? So B1 equals to mu naught is 4 pi into 10 to the power of minus 7 divided by 4 pi. So 4 pi cancels. Current I is given by 1 ampere. And what is the distance? So distance is A by 2 root 3. So A by 2 root 3 means A will come over here and 2 root 3 will go up, right? 1 upon this, that means it will be inverted. Now what is the value of A? Value of A is this. Okay, so you will put that also over here. Okay, so this is the smart step that you have to remember. Okay, so it will be 4.5 into 10 to the power of minus 2. Okay, now what is sine theta 1? Sine theta 1 is this angle. Okay, what is this angle? This is given 30 degree, this angle is 90 degree. So 90 plus 30 is 120, so this angle must be 60 degrees. Similarly, this angle will also be 30 and this is 90, so 30 plus 90 120, so this angle will also be 60 degrees. So both of these two angles are 60 degrees. So it will be sine 60 plus sine 60, that is 2 sine 60. Now this formula is valid even though the angles are not equal. For different angle also this is valid. So now let's simplify. So 10 to the power of minus 2, 10 to the power of minus 7, you get 10 to the power of minus 5 into 2 root 3 divided by 4.5. Now what is the value of sine 60? Sine 60 is root 3 by 2. So root 3 by 2, 2 cancels. Okay, so you get root 3 into root 3 is 3, so you can cancel now. So you get 2 into 3 times 10 to the power of minus 5 by 4.5. Okay, so you can cancel, you get 1 by 1.5. Now this is due to only one of the wire. Okay, so for 3 wires, so this is only one side. So there are 3 sides and it's a circular loop, so magnetic field will be added for each other. Okay, so total magnetic field is given by 3B1 or 3 into, why 3? Because 3 sides. Okay, this is from 3 sides and this 3 is from root 3 into root 3. Okay, so 3 into 2 into 10 to the power of minus 5 divided by 1.5. So you will be getting 2, 1.5 and 3 are basically 2 multipliers. So 2 into 2 is 4. So 4 into 10 to the power of minus 5 Tesla. Okay, so 4 into 10 to the power of minus 5 Tesla. Next question. A circular coil of 100 turns and effective diameter 20 centimeter carries a current of 0.5 ampere. It is turned in a magnetic field B equals to 2 Tesla from a position in which theta equals to 0 it is to be turned in a magnetic field of B is equal to 2 Tesla from position of theta equals to 0 to theta equals to 180 degree. The work required in this process. So basically we have a circular current carrying loop and there is a magnetic field. Okay, and so magnetic field in this direction. So the magnetic moment is also in this direction. Now you want to rotate it from theta equals to 0, that is this initially magnetic field and magnetic moment are in the same direction, right? Now if you want to rotate it from this direction to 180 degree opposition, then what is the work done? Okay, so for that you have to find what is the formula for potential energy. So formula for potential energy is mb sine theta. Okay, sorry, potential energy is always cos theta, torque is sin theta. Okay, so potential energy is mb cos theta. Initially theta is 0 and when you make the angle 180 degrees it will be so initially mb, right, cos 0 is 1 and finally it is actually there is a minus also, minus. Okay, final is minus mb cos pi is 80 degrees, so it will be mb. So what is the change in the potential energy? Change in the potential energy is final minus initial, that is mb minus mb, that will be 2 mb. Okay, so this is the total change in potential energy, and we know that from the definition of work done, change in potential energy is actually the work done. So basically we have to find this value. Now how can we find this value? So what is the value of m? M is defined by current times area. So m is current times area. So what is current over here? Current is given and there are n number of turns also involved. So NIA, okay, National Investigative Agency. So n is 100 turns, current is 0.5 and diameter is 20 centimeter, so radius is 10 centimeter, okay, or radius is 10 to the power minus 1 meter. Okay, 10 centimeter means 10 into 10 to the power of minus 2, which is 10 to the power of minus 1 meter. So area is pi r square, okay. R square means 10 to the power of minus 1 whole square, so that's why I am writing 10 to the power of minus 2. So you have to reduce the number of steps as much as possible. So this is the magnetic field. Now 100 and 10 to the power of minus 2, they will cancel each other, right? 100 and 100 is 10 to the power of 2, 10 to the power of minus 2, they will cancel each other. So what is the work done? Work done is 2 into magnetic moment is 0.5 into pi, and magnetic field is given here 2 Tesla. Okay, 2 into 0.5 is 1, 1 into 2 is 2, so 2 pi is the answer. So correct answer is 2 pi. So as I said, the question is slightly different than you have faced in KSET. The questions, this type of questions never came in KSET. Maybe they have asked you mb sin theta in terms of mb sin theta or 2 mb sin theta, but as you can see in COMEDK question paper or expected COMEDK questions, they are all solvable questions. Now this is a question which I have seen in KSET papers as well, but maybe they have copied it from COMEDK only. A proton, a deuteron ion and an alpha particle having same kinetic energy are moving in circular trajectories in a constant magnetic field. If Rp, Rd and R alpha denote respectively the radii of the trajectories of these particles, then. So first of all, what is the formula of radius of a particle orbiting in a circular motion in a magnetic field? The formula is QB, mv by QB. mv by QB. Okay, if you don't remember this, you have to solve it. mv square by r is equal to qvb. From there you have to solve, and you have to find that r is equal to mv by qb. Right? Now for proton, first we will find the same thing for proton. Mass of proton, okay, velocity divided by charge of proton, that is E into B. V and B are same. Now what about deuterium? Okay, deuteron. Deuteron is now deuteron has one proton, one neutron, right? It is heavy hydrogen, right? So 2 proton and 2 neutron. Sorry, 1 proton and 1 neutron. So mass is 2 of mp, velocity v, but charge is same. Ion means only positive ion, right? So that means it has the same charge that of a proton. Okay, now what about alpha particle? Alpha particle is doubly positive nucleus of helium, right? So doubly positive nucleus means it has 2 protons and 2 neutrons, right? So total mass should be almost 4 mp, right? And v divided by it is also doubly positive. Doubly positive means it has 2 positive charges. So there will be 2e. So it will cancel, and you see that this is 2 mpv by b. So Rd and R alpha are same, right? Both of them are same. So Rd equals to R alpha, but both of them are twice as Rp. So both of them are bigger compared to Rp. So both of them are bigger compared to Rp. So correct answer is Rd is equals to R alpha, and both are greater than the radius of proton. Okay, this is the answer. Next question. 2 circular coils 1 and 2 are made from the same wire, but the radius of the first coil is twice that of the second coil. What potential difference ratio should be applied across them so that the magnetic field at their centers is the same? So we have 2 coils. Okay, suppose the radius is r. Radius of first coil is twice that of the second coil. Okay, so this is the second coil, this is the first coil. Okay, so this, say if this is r, then the radius of the first coil is twice that of the second coil. So first coil has a radius 2r, and suppose the current through this is I2, and current through this in I1. Okay, because first coil has I1, second coil has I2. By mistake I have drawn the second coil first. Anyway, what is the magnetic field at the center of a coil? So B1 equals to mu naught by 2 pi I by R. Okay, I by R. So R is here 2R. So that is why it is 2R. B2 will be same formula, mu naught by 2 pi I by R. Okay, now they are saying that the magnetic field at their centers are the same. So magnetic field at the centers are same means these two should be equal. So these two should be equal means these are constant. So these we do not need to write this. So from there we can write that I1 by 2R equals to I2 by R. So I1 by I2 equals to 2R by R, that is 2. Okay, so this is the ratio of their currents. Now this is not over yet. This is not over yet. Okay, you have to find the voltages. You have to find the ratio of V1 by V2. Okay, so basically you apply some potential difference. That value you have to find. Okay, that is the target. But for that, how can we relate voltage and current? To relate voltage and current, we need to know the resistance. Okay, now resistance of a wire is proportional to its length and inversely proportional to the area of the wire. Now same wire is used, so the area of the wire, individual wire, not the area of the circular loop, area of the wire, okay, that is constant for both of them, and same material is used, so rho is also same. But the length of the wire in this case is twice that of the second wire, right? So resistance of R1 by R2 must be equals to resistance of R1 is twice that of R2, right? Resistance of R1 must be twice that of R2. So that is the ratio. R1 by R2 equals to 2. Why? Because length of one first loop is double. Length double, because 2 pi r. If r is double, 2 pi r will also be double, right? Not pi r square, so it will simply be double. Now what is V1 by V2? V1 by V2 is I1 R1 by I2 R2. Okay, that is I1 by I2 is what? I1 by I2 is 2. And R1 by R2 is also 2. So it will be 4. The ratio will be 4. Okay. Next question. 4 conductors carrying 2 ampere of current into or out of the page are shown in the diagram. So cross means into the page, dot means out of the page. Okay. Now a path C is indicated for the line integral B dot ds. Find the value of the integral for path C. Okay, so this is into the page, okay, into the page, and this is out of the page. Okay, out of the page is opposite, into the page is in the direction of the arrows, right? Curve. This curve is the direction of the curve is very, very important. Now how to solve that? From Ampere circuital law, B dot dl equals to mu naught current enclosed. So what is the current enclosed over here? Current enclosed, let's see. So I1 going out, coming out. Okay, so this is I1 coming out, but the magnitude is same. So it is coming out, this is also coming out, but this one is going in. Okay, but also one more thing, I made small mistake. So if you consider the direction of the loop, okay, anything going in is in this direction, so basically in the motion of the loop. Anything coming out is opposite motion, so these currents will be negative. Minus I1, minus I, minus I. So these currents are coming out of the page, and this current is going into the page, so this will be positive. So what is the total current? So total current is minus I plus I, that is minus I. So minus current will be minus I. Okay, now what is B dot dl? You have to find the value of B dot dl. You don't need to find the integration. Integration you cannot do because the path is not defined. If it is a circle or anything else, you could have solved it. So B dot dl is equal to minus mu naught, and what is the current? Current is 2 ampere, so it will be minus 2 mu naught. Okay, minus 2 mu naught, that is option C is correct. Next question. Following figures show the arrangement of bar magnets in different configurations. Each magnet has magnetic dipole moment m. Which configuration has highest net magnetic dipole moment? Okay, so you have to find the net dipole moment. Now dipole moment for a magnet is from south to north. Okay, south to north. Now in this case, south to north, they will cancel. Okay, so if you see that magnetic moment, they are equal tangent, so m, if this is plus m, this is minus m, so this will cancel. In this case, this is n, this is also n, m, but their angle is 30 degrees. So basically that is not possible to be maximum. The maximum will be case number 1. Okay, because in this case the angle is 90 degrees. So the value will be square root of m square plus m square plus 2m square cos theta cos 90. Now cos 90 is 0, so it will be m root 2. So m root 2, this is the maximum possible value. Okay, for any other combination it will not be the not the possible maximum value, it will be less than that. Okay, so correct answer will be option A. Or so, no, slightly mistake, it is not option A. So what is the formula? Formula is just like vector. Okay, so this is a you have to add the magnitude of magnetic moment in a vector form. So it will be square root of m square plus 2m into m, that is m square cos theta. Okay, so you get this as so you can take m square m common, m into square root of 2 plus 2 cos theta. Okay, so now you have to understand who has higher value of cos theta, cos 30 or cos 60, that will have higher amount of magnetic moment. So for example, cos 30 is root 3 by 2, whereas cos 60 is half. So root 3 by 2 is definitely greater than that of half. So the maximum dipole moment will be for option 3. Okay, so option 3 is the correct answer. Next question. A short bar magnet placed with its axis at 30 degrees with a uniform external magnetic field of 0.35 Tesla experiences a torque of magnitude equals to 4.5 into 10 to the power of minus 2 Newton meter. The magnitude of the magnetic moment of the given magnet is. Okay, so short bar magnet placed with its axis at a 30 degree with a uniform magnetic field. So what is the formula for torque? mb sin theta. The value of torque is given by 4.5 into 10 to the power of minus 2. We are trying to find the magnetic moment of the given magnet. Okay, so we are trying to find the value of m. Magnetic field is 0.35 and the angle is given by 30 degrees. So sin 30 is half. Okay, so we are trying to find what is the value of m. So m will be equals to 4.5 into 2 into 10 to the power of minus 2 divided by 0.35. Okay, so it will be 5 0.9. So it will be 18 by 0.7 into 10 to the power of minus 2 or 180 by 7 or 7 2s are 14 divided by 14 and then we have 40, so approximately 26 into 10 to the power of minus 2. Okay, approximately 26 into 10 to the power of minus 2, or you can say this is 0.26. Okay, so the decimals, how you are tackling it, that is completely up to you. What I have done, I can tell you that first I have cancelled one of them. Okay, 5 was cancelable. Now what I have done, I have removed the decimal. Then I realized if I want to remove both decimals, then it should be 180. Okay, 2 into 19 is 1.8. 1.8 into 100 is 180. 0.07 into 100 is 7. Now I have done the conversion. Okay, so 7 2s are 14. Then we have 40. 40 is not divisible by 7, but 42 is. So 6 7s are 42. So that's why I have approximated the answer to be 26. Okay, so that's how we have solved it. Okay, next question. An electron of charge E is orbiting in a circular path of radius r with a uniform speed v. Its magnetic moment will be. This is a very interesting question. So an electron orbiting in a circular path, okay, with a constant speed of v. Okay, so what is the total path? Total path is 2 pi r. Okay, so how much time it takes to complete one rotation? How much time is taken by the electron to complete one rotation? So that is t equals to 2 pi r divided by v. Okay, so this is the time taken to complete one rotation. In one rotation, the path distance covered is 2 pi r. If you divide it by the velocity, you get the time, right? S equals to vt, so t equals to s by v. Now from the definition of current, we know that current is basically charge divided by time. For electron, the charge is E, and time we have calculated, that is 2 pi r divided by v, or v will go up, it will be EV by 2 pi r. Okay, this is the current. Now what is the magnetic moment? Magnetic moment is current into area. That is the magnetic moment of a current carrying loop. Okay, current we have calculated EV by 2 pi r, and area is pi r square. So pi cancels, one of the r will be cancelled, we get EVR by 2. Okay, so answer is EVR by 2. Next question. The intensity of magnetic field due to an isolated pole of strength MP at a distance r from it will be. So this is very interesting, even though the isolated magnetic pole does not exist, but imagine that you have a isolated magnetic pole and you want to find the magnetic field at a distance r. Okay, so this is same as electric field. What is the formula for electric field? Electric field formula was KQ by r square, right? So basically it will be MP by r square. Okay, there was one mu for magnetic field, but because they have asked you to intensity of magnetic field, that means it is H equals to B by mu. So that's why the mu is not present over here. So answer will be MP by R. Okay, B is magnetic field and H is intensity of magnetic field, that is B by mu. Okay, that is the difference. There was one mu over here. Okay, so that's why it is cancelled. Now next, a bar magnet of pole strength 10 ampere meter is cut into two equal parts breadth-wise. The pole strength of each magnet. So we have a bar magnet, north, south, and we have cut it from the breadth. So there will be a new south appear here, there will be a new north appear here, but the pole strength of the magnet will remain the same. So magnetic pole strength will unchanged if you cut it breadth-wise, but if you cut it length-wise, if you cut this length-wise, then what happens is that one north is divided into 2 and one south is divided into 2 also. So the pole strength becomes m by 2. In case of breadth-wise case, magnetic pole strength remains unchanged. Length changes. In this case, length remains unchanged, but magnetic pole strength becomes half. Magnetic moment for a solenoid and a corresponding bar magnet is equal for both, more for solenoid, more for bar magnet, none of these. Actually, if everything is constant, then there is a possibility that solenoid and bar magnet will behave similarly, right? We know that. So if the magnetic moment for a solenoid and corresponding bar magnet will be the same if they are equivalent to each other. Okay, so that statement is incorrect, slightly incorrect, because it has to be mentioned that it is equivalent solenoid or equivalent bar magnet. Now last question of the day today: if mass is increased 4 times, then the time period of a magnetometer when suspended in Earth's magnetic field becomes. So time period is square root of 2 pi is outside, 2 pi I by m into b. Okay, so I is the moment of inertia. Here m is not mass, m is magnetic moment, b is magnetic field strength. Right, now what is I? I is mass into radius of gyration square, mk square. Okay, it can be half mr square, but generally it is mk square. Okay, now if you increase the mass by 4 times, then radius of moment of inertia will also increase by 4 times, right? This will be the new moment of inertia. So what will happen to the time period? So new time period will be proportional to square root of 4 into time period, that is 2t. So time period will be twice, that is double. So if you increase the mass twice for a hanging magnet, the time period of oscillation will also be double. Okay, so you have to remember this. This formula generally does not come in KSET, but it might come in your COMEDK exam. Okay, because it is not explicitly mentioned which part are covered, which part are not covered, right? So with this note, I am going to conclude this session. If you like this video, don't forget to like this video. Also, all questions that we solved in our lecture, most students have always requested, sir, solve some difficult questions, solve some difficult questions. Today's questions, I believe, are a lot of difficulties and also not super simple. A lot of detailing was required, and I hope you enjoyed. I will be coming back with more questions in future. Till then, bye.